Hey, Kevin. Oh, you died too.
All right, we're back. It is COMP308, that's Emerging Technologies in the Winter 2017 semester at Centennial, and we are week 2, part 1 of our broadcast. So we're broadcasting early this semester, not the second section, the first section only. And there's a couple of things I've done. If you notice online, there is only one section now. It's one big section. I've kind of combined sections into one, just so that way when I share stuff with you, it's shared. Like I don't have to share it twice. I have put a couple of PDFs that are equivalent to the PowerPoints that I will go over this morning. And if we have time today, I'd like to give you information about your assignment 1, even though officially you're not supposed to get it till next week. I want to try to give you an extra week to kind of get into it because it can be a little bit daunting when you're working with new technologies. And although I know some people will wait till the last week to start, I'm going to start thinking about, you know, like I said, I'm going to be doing these like weekly checkpoints with you guys where I kind of get together and then give you bonus marks for having started, right? That means it's optional. If you don't start, you don't get anything, but you don't lose anything either, right? So I will be checking you guys. If I give you the assignment this week, and if you started next week, which is early, that means I'll give you a bonus mark, right? And then we'll talk about those and how that works out, okay? So we're talking about today. I'm gonna bring up the PowerPoints. I want to do a little bit of theory first, and then we'll do a review of what we did last week when it comes to setup. There was a bit of setup, and I want to make sure that everyone's still on the same page. I know some people have setup issues because most people are using PCs, which is okay. I'm just saying, or Linux machines are okay, but for the most part, if you're a PC user, then you might have some issues when it comes to environment variables and setup. So I got to go over a little bit of that again, just because. All right, so we talked last week about mean and how mean can be really mean, right? And I got to talk about that again, right? So we're using this book. This is the book that we're using, Mean Web Development. That's the official book. There is another book that I mentioned last week, which includes this book plus a bunch of other materials. So you can look for that one in last week's lecture. Again, we are also using Slack. So please, if you haven't had a chance to, you know, connect on Slack, I think, you know, this would be a good time to do so. I am going to be using Slack in addition to eCentennial to make announcements and change stuff around and all that kind of stuff. So please, whatever you can do, connect to Slack. It's comp308-w2017.slack.com. You sign up with your Centennial email, and then you can be a part of that conversation, right? Typically, what I like to use Slack for, like I said, is communication directly with you, as well as you know, collaboration between teams. Some people have done things like connect on Slack directly without having to share, you know, phone numbers and all that kind of stuff, which is it's good for everybody. At the same time, you can send people email, and there's the ability, of course, to do voice over IP calls, right? So it's all built into Slack. So if you look at your directory, and there's some people here, if I wanted to do a voice call with Aaron, right? I can go to Aaron and I can call him, right? And I can do a call right from my computer, right? So that's kind of cool. Integrations with Slack, you can integrate things like Google Drive and Git and a bunch of other things. Those are the most popular ones. Plus, I can do things like online polls with you guys, which I've done in the past, and different things if we have to make some decisions. So I mostly share links and that kind of thing. You know, those are the things I want to try and do with you on Slack, right? So it's kind of quick, and sometimes I'll think about a link, or we've seen a new link. Instead of going up to eCentennial and putting it up there again, Slack is just so much quicker, right? So, and that's why I'm using it. So it's not replacing eCentennial, it's just an additional tool set that I'm using. Again, I've got like, if I go to Slack, I got 43 users signed up. That means there are still some people that haven't signed up to Slack. Please do so. All right, so we're using this book. And it starts off with kind of I want to try and do a little bit of intro to mean, more theory today. I got to do that piece because, and I'm not going to read all the slides because this is right from your book, but I also want to talk about it so that we've talked about mean and we're up to speed with the rest of the other sections. There are 2 other sections in this course, hosted by Professor Ilya. He's a coordinator, as well as Professor Nima, I think his name is, right? So he's really good too. They've got different styles than I do, so I'm going to do things slightly differently, but we are following the outline, right? So, you know, in terms of the progression of how we go do things in the course. So again, we're talking about the evolution of JavaScript a little bit, not too much, right? And ECMAScript 2015. I want to go over a few more features today because we kind of talked about a couple of them last week. Talk about mean and NPM and how we do stuff with NPM and what all that is. And this is part 1. So week 2, part 1. There are 42 slides in this deck. There's no way I'm going to talk about 42 minutes on all this stuff. I'm going to kind of skim through this. But the thing to note when we start off is when we talk about 3-tier web application architecture, we want to talk about how most applications are built on the web, which is data, presentation, and logic. We can replace those with model, view, and controller if you'd like those words. Application structure, so that's layers, right? Application structure, those broken into connecting to the database, having some kind of server on the back end, and like web server, and then a client machine, right? That's really what it is. That's the architect. That's the structure behind it, right? You need those things. Modern web development also breaks client stuff into client logic and client user interface. An example of that would be using React, right? So that's client user interface and maybe client logic a little bit, right? But React is front-end framework, right? It's not or front-end API, sorry. Framework is the wrong word. So what's the difference between a framework and an API? Anyone understand that? Framework and an API. And there's also platform. Okay, there's three things we always hear. Framework, platform, API. What's the difference? Right? You're going to hear that. As developers, we need to kind of understand the difference, right? What's the difference? Okay, give me your intuition of what you think it is. First of all, what's an API? Application programming interface, right? Application programming interface. So I got classes and objects that I'm connecting to. Someone's written a bunch of classes that really work nicely. Components. I want you to think about this. I want you to think of an API as a bunch of components that you can plug into your application. All right? You can use some of it, all of it, or none of it. It's kind of almost like a glue that you can tap into. Right? So there's kind of different kind of components, plugins, if you will. Plug it into your web application, and away you go. API. And you can use different APIs for different functionality, right? And then you can plug into your application. An example is if we make a game and I want to have some kind of sound, I might use Sound.js for that's the API for Sound.js just for my sound component, right? But maybe I don't like the rest of Create.js. If you're familiar with Create.js, I'm going to use Phaser for the rest of it, right? Now, is Phaser an API or is it a framework? And what's the difference? So I'd say Phaser is more of a framework, not really, but the reason why I'm saying that is because it's more opinionated and it all kind of hangs everything together. You kind of have to use all the piece parts to make it work, right? As opposed to only some of them, right? So that's the difference for me with when I hear about frameworks and APIs. Those are kind of differences for me. I'm going to try and explain it that way. What about a platform? Platform is a totally different thing. We hear platform as a service, right? We're hearing service-oriented architecture, all those kind of things, right? What's the difference? What is a platform, right? What was that? A collection of software? Okay, I like that, right? So Node.js is a platform, right? That's what it is. Node.js is not a framework, right? Because you can still use components. So you still use npm to download and install components, right? Which is what we're talking about. But it's a platform because it allows you to combine applications or different kinds of applications and different frameworks. This is neat. You can actually combine frameworks to create, kind of a structure or an infrastructure for your web, right? So Node.js is almost like, I want you to think about Node.js as the server side. Like if I was going to look at other solution stacks, and let's talk about some other solution stacks. So first of all, nowadays you should understand the MVC paradigm. Anyone not know MVC and what that stands for? Right? Okay, you should all know it by now because we've done it in COMP308 a little bit. If you're with me on COMP308, then I've done MVC with you. You've been MVC to death with COMP308, right? If you don't know about this model, view, and controller, and you haven't done any of this kind of stuff, and that might be true because sometimes people, we have different professors for that focus on different things. I focus a lot on MVC because if you know MVC, then you understand a little bit more about how things are broken out. We talk about separation of concerns, where we separate the view from the controller, the logic behind the view, and the model that connects with the database. So again, view is the client side, if you will, how it kind of is the presentation side. Controller is the logic, and almost like a mediator that goes, it's a go-between, kind of connects with the model, which is a class or a schema, and the view. And the model is the way we connect to the database. I want you to think about all the database components, the schema, you know, all those kind of things. That should be involved with the whole model, right? So that's, you know, the model MVC paradigm. This is an old paradigm. This is not new. We've been using it a lot lately, but it's been around since like last century, right? 1950s, 1960s, right? We're talking about now. And this is a nice little picture that the book has to talk about model, view, and controller, and how the user kind of interacts with the view. And the view, there's kind of a missing piece here where the view kind of, you know, connects with the controller, and then, you know, that kind of thing. But this is the way they kind of put together in the book, a little diagram that talks about how the model updates the view because it takes, you know, the data from the database server and then, you know, updates the view. The controller modifies the model to connect to the view. And then, you know, the user uses the controller in order for him to get to the model to, you know, produce the view. But the way he uses the controller is he makes a request, right, to the server. So I go to a URL and I say, I want to get this URL, google.ca, right? Well, when you make a request to google.ca, it hits the controller, and the controller says, okay, we need some information, model, get some model and send it to the view and then put it back to the user. That's kind of the full, you know, circle. So this is what I was talking about before when it comes to stacks. We were talking about solution stacks before, and before solution stacks were the AMP stack. AMP stack is Apache, MySQL, and PHP. That's a very common stack. Still hitting 80% of all backend servers, okay? Even though PHP, I don't like it. Maybe you don't like it. You know, it's a little unstructured. It's an embedded language, right? So it embeds inside of your HTML. It's not scalable, you know, as much as the rest. Certainly, you could have a object-oriented flavor of PHP like Laravel, or you can go with some kind of framework, Laravel, right? That kind of thing. But more or less, you know, this again, 80% of penetration. I would say the other 15%. I know you're going to say, well, where's, you know, how do we do Node? 15% is .NET stack, right? Which is so that's 95% right there between the two. The .NET stack, again, you're looking at a .NET server on the back end. So that would be something like Microsoft Azure, right? And then you have, instead of MySQL or MySQL, you'd have SQL, SQL Server, right? That would be the database for Microsoft. And then on the front end, you'd have either web forms, which is 80% of what Microsoft uses still, unfortunately, although we're moving away from it. And MVC, that's also a technology that they have out there. So .NET, ASP.NET MVC, as well as ASP.NET Core, which is the new technology they've come out with, which is cross-platform. So there's two other stacks, right? But I want you to think about the new stack, the new kid on the block. That's why this is emerging technology still, is Node. Node.js, right, would be the back-end server. You could use Express. That's a common way of using it. It's just a module for Node. That's why we kind of say it's mean, because it's Mongo for the database. It's a NoSQL database, so it's not a relational database, a NoSQL database, Mongodb, right? Express, which is just a module for Node. AngularJS, which is a front-end framework. Okay, it's not like React. React would be more like an API in some ways, even though people say it's a framework. I don't think React's a framework to me. React, you can use the API for React to create front-end, if you like. You know, some people look at it as a framework though. And Node, so mean, Mongo, Express, Angular, Node. That's the mean stack, and I think that's the more modern stack to go with. There's an increase in usage, and we'll talk about why. A little bit of the evolution of JavaScript that we want to talk about. It's an interpreted language, right, in general, right? And for a long time, it was very unstructured, I would say. And you can read some of this stuff. People created libraries to make it easier. jQuery is a good example of JavaScript libraries. Very popular library out there still. Came out, I would say, way back in the 90s, right, where we had Netscape Navigator still, right? Anyone remember Netscape Navigator? Probably not. You guys are too young. But Netscape Navigator was one of the first browsers I was using in university. All right, that's what I'm talking. That's how long we're talking about now. And back in the day, just to remind everybody, there was no CSS. CSS didn't exist. You had a Netscape 1 browser, and that Netscape 1 browser, it looked at a bunch of blue links on the screen, and that was hyperlink. markup language. That's what it was, right? HTML was like, really truly in its infancy back then. And they started to bring out something to do with client-side logic because people wanted to do things like calculations. They wanted to show dates. They wanted to do things with the web other than just display information. Originally, it was just display information. Here's my dictionary. Display the dictionary online, right? You want some information about something, you put it up online. In universities, that's where it really took off more. In the beginning, it was all universities, right? The web. So that was the early days of the web. But JavaScript came from that, and JavaScript, it was named JavaScript, again, just as a recap for people who don't know, because of Java, right? Java was out there, and they wanted to complete, so I don't know why they came up with it. And then it was originally called LiveScript. I like LiveScript better still, right? LiveScript. And then they came up with the name JavaScript because it was, they wanted to kind of say it was like Java. It's not really like Java. Java is totally different than JavaScript. There's no similarity really, in terms of structure. However, it is a C influenced language, just like PHP, right? So PHP, JavaScript, they're interpreted languages. PHP would be on the back end. JavaScript would be on the front end, most popular languages, right? Typically at the end of the day. And they were very non-structured, both of them, right? Those were the languages of the days as you moved into the 2000s, right? And then things started to change. People started to experiment and do a little bit of, they've kind of figured out that it was a lot to know, like 4 things or 5 things to be a web developer, right? You need to know HTML, CSS, JavaScript, PHP, all kinds of other design implementations. CSS was also in its infancy. You only had CSS2 at the time. Can you imagine doing things with CSS2? A lot of things you couldn't do with CSS that you can do now with CSS3 back then. So you needed JavaScript to fill in the gaps. There's a lot of functionality that now is included in CSS3 that they didn't have back then. So you needed JavaScript for that. And so JavaScript was also used in an embedded way. You embedded JavaScript in your code in order for you to produce behavior in the browser, right? And they wanted to move away from that. So there's some researchers that came up with, Chrome, or Google came up with Chrome browser, with the V8 engine. With just-in-time compiling. Actually, what this did was, as soon as it compiled, right, the JavaScript, it created C code in the back end, right? I don't know if you know that. So actually, that's why JavaScript runs so quickly now. As before, it was super slow because it was interpreted, right? And as soon as it did that in 2008, things started to change in the web. We could do a lot more with the web back, from starting in 2008 and up until today. An example of that would be enable things like 3D graphics on the web. That would be undoable before 2008 because JavaScript was just too darn slow, right? Slow. You couldn't do anything. And even websites were really slow. And it's funny how things work out because from 2008 till about now, our internet access has really pentupled, or whatever you want to call it. Like it's gone maybe more, 10 times the speed, that we had. The average person now, what do you have? At least 25 megabits at home, at least, right? Whereas before, back in 2008, you're still doing like with 3, right? 3 megabits was pretty good. 5, maybe, if you're lucky, 2008, right? I had 100 in 2008 because I lived in a special building at the time. My condo had, there was a building that was, it had Ethernet right to the door, right? So I actually had fiber to the home back then. So I had 100 megabits back then. Most people had 5, right? So I was like literally sitting on the fiber, right? But for the most part, most people had around 5, something like that, right? Before that it was 3 and 1, and now we're at 25, and for a lot of people are 100. Like I'm at home again, like in a house, and I have 100, right? And some people have more, much more, right? So that also makes a difference, right? Because so what? You have a really fast JavaScript V8 engine, but you can't access it very quick. You have a bottleneck, right? The speed is too slow, right? But now it's not slow. Now you can do things like full-out games, 3D graphics, all kinds of stuff on the web, and it's a good speed, right? So they started thinking about other uses for JavaScript, and it wasn't fast enough at the time. Until 2008, it wasn't fast enough to do JavaScript all over the place. So they started thinking about using JavaScript on the back end. They're thinking there might be a use for this just-in-time compiling stuff on the back end. So we can take away one language, right? Just from, like let's say the server side. And then they thought, you know what if we could use JavaScript on the database as well, right? MongoDB, right? Or other NoSQL databases, NoSQL databases that were non-relational, flat database structure. Because sometimes, relational databases are pretty fat, right? They have table structures, connections, all this kind of stuff, how to connect to the database. And they're really slow sometimes, right? Depending on the kind of database you're using, right? So they're thinking, what if we could just use one language for the back end and for the web, period, right? Not a language for the back end. So PHP as a comparison, right? Or C# if you're a Microsoft person, right? That's the back end language. A language for a query language, so some kind of SQL query language. You need to know that too, right? A language for the front end, JavaScript, right? Structure to structure code, HTML plus CSS. That's a lot to learn for somebody who's just getting into the web, right? And also everything keeps changing, right? By the way, some of that still hasn't changed. So that's where the impetus came from. That's where the kind of the inspiration came from doing that. And this guy Ryan Dahl, right back, he looked at the V8 engine and he kind of said, hey, it'd be really cool. I like how JavaScript can offer kind of a non-blocking experience, right, for the web. And what's blocking? PHP is blocking, right? And I want you to think about this. You make a request to the server with PHP. You have to wait. If you have to wait, that's blocking, right? Why? Because you have to wait for something to occur. Example, I make a request to the server, and the request has to come back. So it's request, server has to process it, come back, response. And I can't do anything while I'm doing that, right? Over and over again. Also, the other thing that people came up with to speed things up was a multi-threaded solution. And you might think that's really faster, right? Because I'm making more threads. Threads are, think about this as little additional cycles of work that you can create on the same server. So I can give, let's say, Aaron a thread. I'm going to give, Omid a thread, right? Arlena, I'm just looking at this row here. Seth, I'm giving you all the threads. What about the rest of you guys? What if you don't access my server? I've got all these threads that are sitting there waiting. I got a lot of idle threads, right? That causes load, right? So because I have to kind of, create these extra threads just in case there's going to be other users on my website, right? So Node.js uses a single threaded kind of model, which is, how does that work, right? So again, things didn't work out. They tried to build this platform, Node.js, but it didn't succeed because they had some issues. And then finally, they kind of created this V8-based database called MongoDB. Came from the word humongous, right? For NoSQL. This is where this is the evolution of how we got there, right? So that was that part. They got that up and running around 2009, right? And then Mongo, kind of gained a lot of ground. And then finally, when Mongo was up and running with all kinds of things that you could do, and similar to what you can do with additional databases, right? Finally we're able to use Mongo. So we have Mongo, we had Node on the back end, and we have JavaScript on the front end. But then you had some issues, right? You had some issues where, you still had to go and do that round trip stuff, right? And that round trip stuff slowed down the front end, right? Especially when it came to refreshing the screen and stuff. Let's say, example, you went on the back end, you updated a record, equivalent. A record is called something different on MongoDB, but you updated a record on the database just to give you the same lingo, and then you have to wait for it to come back anyway, right? And the thing is, you have to refresh the screen somehow, right? Well, that was a problem, and they wanted to use some kind of Ajax-enabled framework, right? jQuery-enabled framework. And what jQuery-enabled framework do they make? AngularJS, right? It uses JQ Lite, actually. The original Angular 1 that came out used JQ Lite, jQuery Lite, that was built into AngularJS. So again, jQuery makes Ajax easier, Ajax being asynchronous JavaScript and XML, right? That was the original name of it. Now just call it Ajax, right? Don't worry about what it really stood for before. It's not the same anymore. But it was kind of this idea of a rich web application framework, right? That they wanted to kind of put in that included something called two-way data binding, right? So the idea for them that when you updated something on the database, you have an automatic update to the screen. The database would push to the screen as opposed to you pulling. That's a whole different experience, right? Now, there are opponents of this kind of thing because they say, oh, the two-way data binding is bad. It causes load on the server. you know, all this kind of stuff. And this way they have this, that's where React is different. React does not use two-way data binding like Angular. Doesn't do it the same way. And the other thing was with Angular, there was a rise of this single application, page application, you know, framework, these SPAs that came out. That's what they used to call it, right? Because I could fill my page with content dynamically based on my choices, right? I don't have to have different pages. And if I only had one page, right, one long page, but I only displayed part of the page, I could, you know, give the user experience the idea that they had multiple pages that they were going to, but they're physically only on one page. And if I'm only going on one page and I got to switch pages, I don't have to make a request to the server, which means I'm not going to get a response. I don't have to go do that round trip, which means my experience is quicker even than before, right? This whole single page application framework, which we do with Angular. And you can also do with Ajax or React, right? But that was the idea, right? So again, this is how everything evolved, right? So again, Angular gives us other capabilities other than just two-way data binding, including things like dependency injection, which is still there today in Angular 2, as well as MVC-based components, which is the big thing that's in Angular 2. That's different than in Angular 1. A lot of component-based architecture, right? It also gave us the ability to break up methods to create units, right? You know, like units of work. Methods is how we can test the web to make sure that things are working properly. And you can use test-driven development, right? That means I can start off with a unit that doesn't work. It'll fail the test, right? And then I build my unit based on what I require, my method, whatever feature I want to add. And when I'm finished building the method and these are the expected results, it's a different way of thinking. Test-driven development means I want to kind of say, here's what I want for this method to do, right? Whatever this method does, whatever the feature that it's going to add, right? Well, it's failing my test because it's not doing it yet. Okay, fine. Let's build on the logic to do the test. Does it pass? Yes? Good. That's unit testing, right? And in a nutshell. And, you know, we weren't able to do this as easily without some kind of front-end framework that had this two-way data binding, the component-based approach. Because of components, we can break things out, so it's more modular than, you know, one big, humongous web application. And so this now we get back to the idea of this full stack JavaScript. So whenever you talk about someone who's a full stack developer these days, there are those three, you know, stacks, the solution stacks, right? So if you go on your resume, you should put down what solution stacks do you know. You should put a section there that what do I know? Do I know the AMP stack, LAMP, MAMP, WAMP, some version of the AMP stack? You should know, right? You should know this as a web developer. Does everyone know AMP? Some degree, Apache, MySQL, and PHP. If you don't know that, right, that's 80% of work out there is that, right? Then again, that 15% is that .NET stack, right, which is .NET, right, SQL Server, and some kind of web forms or web ASP.NET MVC and ASP.NET Core. One of those. That's the .NET Microsoft stack. You should know that. And you should get that from, like I said, COMP308. You should have had some exposure to that. And now you're getting the mean stack, which is that extra 5%, right? And I'm not even 5. I would say 2, right? 2%. You're like, oh my God, why are we learning this stuff? And I told you last time, there's big websites that use Node, and so don't discount it. And it's on the rise, right? It takes time for change to happen, right? And if you and I invested in you know, this architecture, and it still works, what's my reason to change, right? Think about this. I have PHP out there. My website works. My database is going. I'm a big company, right? And front end, I can change the front end, right? Because I can make it responsive. I can do all those changes on the front, but the back end, that stays the same. I don't want to touch it, right? Because it's a lot of change. Migration from one database system to another, you know, that would be one. And the other thing I want to also point out is this, right? Remember that there are still different solutions that you can't use Mongo or NoSQL database, that it's not the right solution. Right? You might have a problem where you need relational database in the back end, right? It makes more sense, right? Now, it doesn't mean that just because we're talking mean stack, it doesn't mean that you have to use Mongo, right? There are other NoSQL databases you can tap into, CouchDB as an example, right? And you can also use other things out there, right? Anyone know of another kind of backend other than Mongo that you can hook into that's really popular by Google? Firebase, right? Firebase is huge, right? And that's another kind of no SQL database service that's offered by Google that's purely online. It's awesome. Obviously, with Angular, they have something called Angular Fire, right? Angular Firebase, Angular Fire. That gives a whole solution set. Let me put this up for you, because Firebase is really popular. And Firebase is awesome also because you can connect it as a backend for mobile technologies. So you want to have a backend. We're going to talk about microservices later on in this course, right? But Firebase is awesome because it is, again, supported by Google, amazingly documented, like way better than any other that I've seen, right? You can start off for free, right? And it has different plugins, right? Depending on what kind what kind you want. For example, for iOS, for Android, for the web, those are like just to start, right? So this is really cool for me. And they have different getting started guides for getting you going. If I go getting started for the web, because we're talking about the web, you know, you can start looking at different solutions. Like they have getting started for Unity, for C++, for different things. It's pretty awesome what you can do with Firebase, right? So if you haven't heard about Firebase, it's pretty awesome. Here's Node.js, right? How do you connect with Firebase and Node, right? We're going to talk about this as well, because Firebase is a great swap with Mongo, right? So let me just put that. I'm going to go back to Firebase and just shoot this, if I can, on Slack for those people who are remote. So I'll say check out Firebase. Awesome, right? Really cool stuff. There's some really cool courses out there, like tutorials and all that kind of stuff that talk about Firebase and how to connect it with different apps. It is on the rise, and a lot of big companies are starting to use Firebase. Okay, so again, going back just to talk about this mean stack architecture, right? Again, it's a three-tier. We talk about three-tier web applications, right? Unified under JavaScript, which is I like the way they put that in the book. And the mean stack is just a single example. It's not just one. We're talking mean stack in this book, right? But it doesn't mean it's the only thing. You can replace some of these letters, right? Instead of Mongo, you can use Firebase. Instead of Angular, you can use React or some other front-end framework, right? You don't have to do it this way. In fact, we're going to focus a lot in this course on Express, making an Express application for the beginning, right? We're not going to touch Mongo right away. We're going to wait a week or so, right, to touch Mongo. And then it'll just be Express, Node, and Mongo. And near the end, we'll kind of, you know, give Angular a glancing blow, right? And I'll tell you why we can't do a lot with Angular, right? Not because I don't want to talk Angular. Angular's really cool. Angular 2, which is what this book is all around, uses TypeScript, right? Component-based architecture. If you don't know TypeScript, you need to learn it, right? Because if you don't use it and you use pure vanilla JavaScript, there's some disadvantages to that, right? It's complex. Level of complexity is high. It uses advanced things like closures, which we're going to talk a little bit about today, all over the place. And when you first look at it, it's not intuitive. Just saying, right? The setup is a little finicky in terms of setup. So, you know, some people have gone away from Angular because of all this. Plus, it took a long time for Angular 2 to kind of emerge, right? It's React, right? Or some other front-end framework, like Knockout.js, right? Or other ones. All right, so that was really all around the rise of JavaScript. I had to talk about that a little bit because it's not just a theory, but for you guys to have a thorough understanding of where everything kind of evolved from. ECMAScript 6. We talked about ECMAScript 6 or ECMAScript 2015 as it's now called. Some people also call it ECMAScript Harmony. Those are the three words that you might hear, or the three kind of way of describing it. But really what it did was it kind of moved us into a direction where we wanted to bring object-oriented design methodologies as well as additional feature sets that JavaScript was missing, right? Around the world, we're asking for, right? They're like, hey, how come I can't do a class in JavaScript? Well, because JavaScript isn't class-based. It's not a class-based architecture. It's more functional programming, prototyping, right? Why can't we do it? Why can't we set up that syntactic sugar around JavaScript to create a class-like architecture? Because we all learn object-oriented programming. Wouldn't it make it easier for programmers to learn JavaScript if it was object-oriented as well? Because if you learn classes and objects, then you can create that structure. And who cares what it looks like on the back end? Yes, but that's not JavaScript. There's a whole argument around it, right? Finally, the people who wanted those features won, right? And in June of 2015, they kind of adopted actually July, I would say, they kind of adopted the that kind of thing. So some of the common features, we didn't talk about this too much last week, was modules. The ability for us to break off, JavaScript into different piece parts, right? Because normally it's hard. You'd have to use some kind of other modular system. You have to download and install different things to make modules work with raw JavaScript. And on the back end, we wanted modules to be, much easier. So again, I want you to think about Node originally using something called require.js. That was what it was called. And require.js, it uses the CommonJS principle of kind of linking everything together, right? So I would require a module. That's very true still today. I require a module, right? I can make my own. Let's say I have different, I want you to think about having different documents, right? So let's draw this out. Forgive me, I'm going to bring up a drawing program because I can't use a whiteboard because then you wouldn't see it on the video, right? So I'm just going to use, maybe not fireworks, not today. Maybe I'll use my other, starting to rise for me, my favorite programs, right? They kind of changed into more Sketchbook Pro. And I probably should bring out my little tablet, but anyways, let's suppose you have a document. So here's that's not a document. Let's suppose, let's get this going, right? Let's suppose you have a document. Here's a document. And what you want to do is you want to access this document over here, right? And what happens is maybe there's other ones like, this one over here, right? And these documents have different pieces of code in them, and you want to include it in this document over here. Well, with an index.html file, typically what you would have, right, is you'd have some kind of in the head of your document in HTML, you'd have different sections, right? There's in the document object model, you have your HTML. Let's think of this as an HTML page, right? And then you have the head of your document, and you have the body of your document down here, right? Simple enough. And what happens is normally in HTML, what you have is you have this link inside the head of your document for, let's say, a CSS page, right? That's how it works. And then in the interpreter, what happens is I keep going down line by line. Let's say there's all these lines, right? So here's different lines in my code. Just imagine these code. And what happens is the interpreter goes down line by line and starts reading these lines and including different piece parts into your index.html page, right? So I take CSS. When I get to this part, I take my CSS, and this whole here, it kind of injects that whole document right into the page. Physically in the cache, in the browser cache, that's what happens, right? So everything in your CSS page, every little thing that you put in there is right here on line 3, let's say, right? That's huge, right? That's great too. That's how it should work, right? And then let's say you have some kind of JavaScript module that kind of goes at the bottom of your body tag because we don't want to put it in the top just in case the JavaScript fails and then this whole content would be blocked, right? That's nice if we had an index.html on Node.js. But do we have index.html on Node.js? No, we have no pages on Node.js. The server side doesn't have an index.html, right? So how do we do this on the back end? Modules. And we need some way of requiring modules at different places, just like this, right? So we use the require.js or CommonJS is what we use, modular system, where we can require this module. Imagine this is not an HTML page anymore, but rather a node, some kind of node application. So this is we'll just call this node application, right? Here's my node app, right? Let's move this over here. So here's my node app now. And with the other maybe over here, right, in this module, right, we're going to have this one. That would be some kind of component, or let's say, for example, my routers, my routing. So I have my routing, right? Here's my routing, and my routing is up here, right? So my routing has a routing table. So when I go to, for example, which page of my web app, because remember, my Node.js acts like Apache, right? And if you know Apache architecture, the Apache server, what it does is you send a request to the Apache server, and it says, oh, what she means to go to this particular file, serve up this file. You're looking for index.html? Here it is, right? You're looking for contact.html? Here it is, right? That's what the routing table does. Depending on what you're looking for, it finds the file on the file system and serves it up, right? So we might have a routing file that we want to kind of tap into. Do I want to put it all here in my Node server document? No, hell no. That's going to be really long, right? I want to break up my code a little bit, right? So that's routing. What about if I have to connect to the database, right? Maybe I want to have some kind of schema, right, to connect to the database. So we'll say a DB schema, right? Some kind of database schema. Well, that might be where exactly we want it. Some kind of database schema that's separate for the rest of this document. We separate our concerns, right? Routing, database schema, like views, right? Let's draw another little thing there, right? So I want to draw another rectangle over here. Let's see if I can do that. Oh yeah, I got to go down here to this layer. So here's another document down here, and this is all of our views. We'll make it a little longer, right, so we can fit. And so these are all our views, and views are just the HTML pages. That's what it is. Right? So all those HTML pages, which we call views, right, in the model view controller, we want to link all that in there too, right? So that's the thing. When we start going there, right, when we start doing that, we want to kind of link it into different places. Sorry, I keep switching things there. So maybe I want to put that over here, right? Some in the bottom. And I can only do that with something kind of like some kind of modular system. That's how we build our Node app. Our Node app, we have our main server.js module, typically, or an app.js that is one page, and we use it as a manifest to link all of our different pages and functionality together. In addition to third-party modules that we have to download and install. An example of is if I may need some kind of middleware to connect from my database schema to my database. So let's say we have a database store. So here's our database somewhere over here. Database, right? So here's our DB. Whatever DB it is, you can use Mongodb, Firebase, whatever. Even if you want to use SQL, some kind of SQL database. Here's our database, right? And we want to connect to it with our schema. We have to have some kind of middleware to connect to the database, right? So we have to plug that in, and there might be a module, a third-party module, and in this case, it's called Mongoose, if we're going to connect in with a Mongo database, right? That we have to load and install in our Node application over here in order for us to provide a link from our database schema, which is just a class that kind of talks about what's the structure of our database, like what does a record look like, right? Do I have a name? Do I have age? Do I have telephone number? What's our record look like, right? That's our schema. And then how does that connect to the database? That uses a third-party module because Node and Express is very lean. I want you to think about this, right? When we build applications with Node.js, everything is lean. It's like the bare minimum that you're going to get. You're going to get nothing, right? Like we're going to talk about Connect today, right? Which is kind of middleware that we're going to be talking about. That kind of was the first evolution before Express, right? And Connect is bare bones. You get nothing. Right, like literally, you don't get anything. And then they came up with Express, which is much more robust in terms of all the things that you can do, right? And that's the Node architecture, so to speak, right? So again, I probably want some kind of link, some kind of middleware that goes from here to the database. Now, I won't go exactly from here. There's going to be some kind of, third-party module. And I know this is kind of weird to draw it out, but here's this third-party module out here, right? And this third-party module, and this we call Mongoose, is also linked to the Node app. Right? So this functionality enables us to do this, right? And so a Node app can start really small, and as we add functionality through NPM, right, Node Package Manager, like we did last week, right, we continue to add until it becomes more robust, and only the functionality from in a component-based way that we need, and the rest of the functionality we leave. So I want you to think about it, and I hate to use this analogy, but I like to do this sometimes, like a big Chinese buffet, right? You want to, maybe you ever do anyone go to dim sum, right? Or you go to like an all-you-can-eat place, right? Maybe even that's maybe a better option, right? You're going to only get the food that you want, right? Maybe you don't want everything, but most times your plate is pretty full, I have to say. You go there and just overeat. You eat, right? That's the thing with Chinese buffets or anything like that, or even just some kind of all-you-can-eat place, even if it's not Chinese. But the example is the same. It's like you take what you want and you leave the rest, right? It's almost like, you can, using your own personal choices, you can choose what you want and from a priority perspective, attach the functionality you need, and then not attach the other stuff. So everyone's Node application might be slightly different based on what your requirements are, right? Which is different than Apache. Apache, for the most part, uses a lot of common modules, right? And yes, you can add there's different functionality that you can add to Apache and MySQL and PHP. There's also modular, right? But the adding on, usually when you go onto an Apache server, it's not like you have a lot of choice. It's not like you can go up there and completely modify or put whatever you want in there, right? So you have less control with those kind of things because someone's built it for you. You usually go on some kind of provider's website and they have every functionality that they've kind of put in there. And that makes the Apache server a little bit slower and more clunky and less secure than, let's say, something like a Node app where you can lock it down with different modules and so on. Okay, so I'm just going to kind of get to this analogy. This is why I'm talking about this, so you understand. Because this is really as messy as it can be. And I can keep, by the way, I can keep adding third-party modules in here, right? So I can, keep drawing different modules. So let's say you might have other ones over here. Another module, it might be another module for functionality, and another module for functionality, and another module for functionality. I'm just thinking about them in order, by the way, right? And then they all might link here at the beginning of the top of your document. It'll be like a lot of that. You'll see a lot of requires at the top of your document, right? And then what happens is then you have some kind of functionality. And the HTML pages, what happens is this is where the controller comes into play, because you might have another which I didn't mention before, some kind of application logic that links to your Node JS or server JS application, and we'll just put it over here, right? So some kind of here's your controllers, right? And this controller basically controls all this path and feeds, right? Takes all this information and feeds the views with the stuff that we're going to get from the database. I know it looks crazy, but that's what a Node.js app looks like, right? And so it's daunting for some people. It's a little bit scary because they look at it and go, oh my God, I don't know how to link all this together. It's crazy. How does this connect to this? And how do I do this? And how do I do that? And for beginners, that's the biggest problem. When you look at a Node application or even an Express application, so these are controllers, you're kind of trying to figure out where the hell does everything go, right? Yeah, let's put this up so you can see it. Right? How does this all work? I don't understand how this all links together. And so that's where we come back to the idea of modules using the CommonJS module framework, right? And so what we can do is we can use two keywords, export, and then I'll take a break after this when I explain this, right? Because we need to kind of, you guys are phrasing out, some people are dying, right? Export and import, right? So we can export, again, if I go back to this example, right? This routing table, right? I want to kind of do something with the routing, right? Well, what I want to do is use the export keyword, right? So let's say I want to export my paths, right? I want to export information, so I can export from this module, and then I can import into this module. So I can export means I can expose. And by the way, if you've done TypeScript with me before, it's very similar. I can export. I can expose different parts of or objects inside of my document that are available in the other document. So example, I can write a function over here, use the exports keyword, right? And that function now is available in any module that imports the routing module, as an example, right? I can attach it. And once it's attached here, it's part of my cache, which means it's available in most other places, right? Doesn't mean that because I've exported it here and I've imported it into here, that it's available in here. This can be its own closure, its own module. And in order for this routing table to be available inside, I don't know why I would do this, by the way, there's no reason for you to do this. But if I want to make my routing table available in my database schema, I'd have to import it in here as well, right? I only export or import the stuff that I want to expose and include inside of my my documents. Okay, so just the words, export and import. And that's what ECMAScript 6 allows us to do. Before it was done slightly differently. Here's a piece of code that can give you an example of that, right? So I have a function, right? And let's say half of, that's the function, and it takes a parameter x and it returns half of x, right? X divided by 2. By the way, should I write it this way on the web? Well, it's a better way to write this. Times 0.5, because division is much more heavier from a calculation perspective than multiplication. Always, right? And so that's the way we should do it. It's a far easier way of doing this. Makes the things think a little bit more. And if you have a lot of this happening, like many calls that does division, it's negative. You don't want to do that. Multiplication is much far better if you can handle that, the changes, right? All right, and then, so here's main.js. So here's, let's say this is a lib.js module. Let's say as an example, you're making all these libraries of mathematics, right? So this is a different file altogether. And let's say you have a main.js module. And then what I want to do is import. So here's where I'm exporting. I'm exporting this function. So I'm making it available outside of my document called lib.js and inside the document called main.js, right? And then when I import half of, so I give it a friendly name. I want you to think about this. Half of is the name of the function that only lives and breathes inside lib.js, right? If it's in a different file, it has nothing to do with main.js, right? But I want to make half of, the word half of, or I want you to think about this as an object, right? Become a reference to this function, right? That's what it is. It's almost like in C++, a pointer. It points to this function, right? That's inside the cache, right? So now I can use half of, the name half of, the same way that I would use it here in lib.js. I can use it in my main.js, right? So it would be half of, so I go from lib. This is from means where it's coming from. Usually we want to include the path, right, of the module. If it's in the same folder, you just put lib. If it's in another folder, you'd use pathing to do it, you know, ... if it's higher level, or if it's in the same folder, usually sometimes you see it say /. That's more common. / means it's in the same folder, right? And you don't include the JS, right? So you don't sit there and go, you don't have to go JS. You don't have to put lib.js. You could if you really wanted to, but we can omit lib.js because we assume it's a JavaScript module, okay? And then if I was to console log would spit it to the console, right? And if this was a Node.js module, where is the console again in Node? Your terminal window, not the front end browser. Normally, when we think console on the browser, we think it goes right to the browser, right? We do our debugging there. Not so with Node.js. It goes on the terminal or command prompt. That's where it appears, right? So now what would this do? Half of 84. What would it return? Right? Half of 84. It would take this because we've included this in our context, right? In our main.js context, inside the scope of our, I'm trying using different words to get it, right? In the scope of this file, main.js, now half of means this function. I'm referring to this function in another module altogether, right? When I use import, what does it do? It takes that function and literally plugs it into main.js. It's a part of main.js now, and it lives in half of, right? So every time I refer to half of, I'm referring to this function, even though it's in different modules. So it gives us the ability, and this is ECMAScript 6, it gives us the ability for us to have, you know, our modules in different files. We can chunk out our code so it's not as difficult to follow if it's really, really big, right? Imagine like thousands of lines of code. Oh my gosh, where is everything, right? As opposed to, oh, here's our routing table. Here's our database schema. You know, here's our Mongoose configuration. Here's our authentication configuration with Passport. Here's our other parts that we want to add to our file. Here's our application logic for Angular, right? And all that kind of stuff. Modules. Here's some more examples, right? So you have lib.js, and now you have two modules, right? You have half of and multiply, right? Well, if I want to include more than one, I can do it this way. I can say import half of, comma, multiply. So both of these two modules, right? Both of these two exports, I need to import, right? I need to use an import for each one of them. And I'm giving them friendly names, half of and multiply, right? I don't have to call them this. I can call them whatever I want, right? Because the receiver, this is the sender, right? Lib.js, he's exporting. Exporting is sending information, right? And if I import, I use the import keyword, I receive whichever module I want. If I only want to receive half of, and I don't want to receive multiply, I don't have to. I don't have to take everything. And what if I want to receive everything? Star, right? Import star from lib, and then I can use it, right? That means they're going to take the exact same names. So be careful, right? And so you can see that how this context works. So I can multiply two numbers, you know, by having it live. All my libs, my library file has these two functions, and I can import them here in my main, but I don't have to have the functions living inside of main. They can live in another module. Also, the other thing you can do is create something called default exports, right? The default keyword is something we can use that's new in ECMAScript 6, right, or ECMAScript 2015, or ECMAScript Harmony. I'm going to put those out there too. And when I use the default keyword, You know, as an example, if I say I want to import something, right? Import, I'm saying in this case, do something, right? From do something. Here's my do something, you know, module, right? And here's my main. It's going to take this module, default, even though it's not called do something, right? It's the default one. It's the default export. This is the one that if I import something and I don't mention the actual function itself by name, this is the one that's coming. So there's options you can do with that. Sometimes that's really important to do. So I only want, if I don't mention anything, that's the default module that comes. But if I want to, I can specify other ones, right? So again, modularity becomes more, you know, kind of pick and choose. Last one, which you'll see a lot as well. Here's my validator.js, right? And what you can do is you can export different things as well as variables. Here's a variable with the, remember the let, what's the difference between let and var? We talked about this last week, huh? Hoisting, but I want you to think of it this way. Let, right, when you say let, it actually maintains scope, right? That's what it does. I want you, that's the key thing about let. And in fact, if anything, we should always use let, right? We should go away from using var now because it's supported, right? So if you see me using var, right, remind me to use let because it's an old habit, right? Still I'm using var, right? We should be using let in everything that we do, right? However, going back, when you're programming for the older web, sometimes let is still not understood, right? Like older web meaning older browsers, right? And they're still out there. I don't know why people still have this old browser. They don't want to upgrade, especially older people who don't want to do stuff, or if they have an older device, right? They don't want to upgrade. Those let won't work, right? It's just letting you know. So it might cause issues. Most likely not, right? So here's an example of we're exporting not only a function, but also some kind of data store variable, right? And we want this variable flag to be available inside another module, right? So here's main.js, right? So not only do we export functions this way, but also modules. Now here's something, right? I got flag and touch. This is an interesting thing here. If I do a console log flag here, right? And I haven't called the touch function, what's the value of flag? False, right? And that's what this is saying down here. And now if we use touch, right? I don't know, this module touch, I kind of referred to it, right? Now it's going to turn true, right? So again, you can modify things here, even though you're not modifying flag, the value of flag physically within the module. That's new, that's a different thing, right? Because before we can use something, but we didn't have access to some kind of, I hate to say this, global variable, which that's what flag becomes, right? Flag now is globally available to the main.js, right? To the main.js module. I have to save that. But that's what happens. You know, flag is now globally available there. It's available anywhere inside the main.js context, right? Because we've included it, we've imported it inside of our file, right? Now this is really, really important stuff, guys. I'm gonna pause here and we're gonna continue with the rest, right? And I've spent a little bit of time here because this is kind of the basis for how we do stuff in Node. If you don't understand this, right, when we start requiring stuff, you're gonna be like, Tom, can you explain that again? Because I just don't understand, right? It's like, you know, it's the kind of the basics, yeah.
How about I define another flag in the main.js?
Okay, all right. So if I did that again, if I said let flag do, you know, equal to whatever, what am I really doing? Flag, because I'm doing it here, right? Importing flag. And if I try it again, it's not going to give us an error. It's going to overwrite the reference, right? So it's going to start, instead of pointing to that one, it's going to point to the other one if it's the same name, right? However, if it's within a function, right, there are going to be two. There's going to be the flag that's globally available, and there's going to be another flag, this dot flag, that's available within inside that function. Right? And you can use the this keyword for that, right? So be careful. I mean, you don't want to try and do that. That's bad, right? You want to try and use different keywords, but yes, it would be overwritten if you try doing it. You can try it out. I would recommend experiment for yourself and see what happens, right? So let's take a break. Let's take a break, and when we come back, I want to talk about classes really quickly and how classes, you can use classes in ECMAScript 2015 and how that works without using TypeScript again. This is, remember, we're using some functionality now, which I'm loving, right? Because before we had to use TypeScript and convert it all. Now we don't have to do that. Okay.